Okay, let's look at the section 1.1, describing sets. Right, first, let's define set. Right, so here's the definition. A set, so this is the word we're trying to define, is a collection of objects. Right, so it's just a collection of things, and it could be numbers, it could be a collection of fruits, it could be a collection of letters. Right, and the objects are called elements. So elements of the set, right? Or you can use members if you want. All right. So here's how we describe a set. Right. So for example, and set A, and it is customary to use the uppercase letter for the name of a set. So A is equal to, then we use curly bracket to enclose the elements. So we list the elements, say A, B, and C, then put curly brackets around them. So this is a set containing A, B, and C. All right. How about B? When you have just too many elements or infinitely many elements, we have this convenient notation called three-dot notation. So this guy right here is called three-dot notation. If I can spell it, three-dot notation. Right? So if you want to have a set of all positive odd integer, then you say 1, 3, 5, 7, then you put dot, dot, dot to indicate the same pattern just keeps on going, right? So that everyone knows what which integer belongs to this set. All right, and another way to describe a set is it's called the set generating notation. Set generating notation. All right, so this one basically has, okay, so you have an element x, then this vertical bar, some people use column too, so you can use either one, but you can think of this guy as such that, right? So set C is a collection of element called X such that it satisfies this equation, right? So if you solve that, actually we can factor this out. So this would be x plus 2 quantity and the quantity x minus 3 equal to 0. So x equals -2 and x equals 3 would be the solution of this equation. So therefore, set C is actually exactly the same thing as a set containing -2 and a +3, right? But this is another way to describe a set. You have x, then you give a condition right after the vertical line or a semicolon. I mean, it's after a colon. All right, another a set that we need to know is empty set. Empty set is a set with nothing in it, so you can actually use this notation, or you can just put the curly brackets without listing any elements, right? On the other hand, there is something called the universal set, right? So this is a set with everything in it. So universal set, the notation is usually U. U is, this guy is the set of all objects under consideration. Right? All right, so if you're talking about alphabets, and universal set would contain all alphabets. All right, and another thing we need to know is cardinality. For finitely many finite set, cardinality is exactly the same thing as the number of elements. So for example, so cardinality, right? The notation is cardinality of, for example, set A would be, right? Since we have 1, 2, 3 elements, so cardinality is 3, right? Then the cardinality of C here would be, there are 2 elements, it's 2. And the cardinality of the empty set, since there's nothing in it, it would be 0, right? For a finite set, that you can think of the cardinality as the number of elements, right? For infinite set, we're not going to discuss it since we have a section talking about cardinality of infinite set, so we'll postpone that later. All right, that's it. I hope that this was clear.